हेलो। हाँ शिवम, अभी टाइम लगेगा क्या? हेलो।
हाँ नमस्ते। हेलो मैम।
हाँ, अभी टाइम लगेगा क्या?
मैम का आवाज नहीं आ रही था। हाँ हेलो मैम।
हाँ, आवाज आ रही है आपको मेरी?
हाँ
हेलो।
हेलो। जी मैम।
आवाज आ रही है आपको?
हाँ हाँ मैम। तो
अभी कितना टाइम लगेगा आपको?
वी कैन स्टार्ट मैम।
हाँ, तो स्टार्ट करिए ना फिर। हाँ,
यस यस मैम, फॉलो स्टार्ट कर रहे हैं।
ठीक है, स्टार्ट करिए।
यस यस मैम। जस्ट जस्ट वेट वेट। हाँ हाँ। हाँ हाँ बैठिए, स्क्रीन की तरफ से बोलिए। हाँ। Healthy good morning to all of you of for offline session, that is the 8th session of Atal FDP program, Hybrid Microgrid opportunity and challenges for renewable energy resources. I am Dr. Shivam, Assistant Professor of Electrical Engineering Department, NIT Kurukshetra, co-coordinator of the Atal FDP. Heartily welcome Chief Guest of the day, Dr. Dahiya. He is Professor and Head of SRE as well as coordinator of the Atal FDP and faculty member and participant of the event. The primary objectives of the Atal FDP is to provide a national forum to the faculty and research scholar to share the basic knowledge with an objectives of understanding the concepts, aspects of penetration of renewable energy sources, electric vehicles, and with hybrid microgrid operation. Now I would like to address of today's session speaker, Professor Ratna Dahiya. Currently, he is professor and head of SR, School of Renewable Energy Efficiency. She has lots of work experience. Right now, he is coordinator of School of Renewable Energy and Efficiency, as well as he did head in the electrical engineering department, NIT Kurukshetra, and she become director, Kalpi Institute of Technology, Kurukshetra University, Kurukshetra. She has published international and national papers. She is guided more than 20 PhD and more than 40 MTech dissertation. She has organized many workshops and short-term courses. Among that, second international conference on a smart grid energy system and she is organizing faculty development program, this FDP, and also she organized PyCon conference in 2018. So there are many activity has she covered. Ma'am has area of interest in microgrids, has power system. So now I would like to welcome ma'am. Welcome for this session. Good morning, ma'am.
Thank you, Shivam. Good morning. Good morning to all the participants. I hope you are hearing my voice. All of you can hear my voice?
Yes.
Okay. Please share the screen. Slide view. Put it on the slide view. Shivam, put it on the slide view.
Is it okay, ma'am?
Put it on the slide view. Slideshow. From the starting. From the beginning, yes. First side. From beginning. Slideshow from beginning. Yes.
Ma'am, it is not showing slide mode.
Idhar hai na? This is from beginning. It is showing, I can see it on the screen.
I have already changed, ma'am, but online we are not going to see this.
Okay. Anyway, so just, can you enlarge this? No.
वहीं से चेक करिए तो वापस स्क्रीन पे जाके इसको यहाँ से एक्सट्रैक्ट करना पड़ेगा थोड़ा नहीं इसमें नहीं
Okay, if you cannot do it, it's okay.
पीछे नहीं हो रहा बैकग्राउंड में ना
No problem. Let's start. Is it visible to all the participants?
Yes, ma'am.
Okay, good. So let's start today's session. In this FDP, you have been hearing so many topics related to microgrid, and I think you have the good exposure of microgrid, the introductory part, what are microgrids, and how the microgrids are operated. So some of the topics have been covered by eminent speakers. One topic which I have selected to give you just an idea of this topic, that is economic and environmental benefits of microgrid. Actually, whenever you go for any microgrid or any system, you first of all, as an engineer, you have to see that what is the economics behind it, because whether it is feasible or not. Another point is it should not be hazardous for environmental effect. So these are the two major reasons why I have selected this topic. Maybe this will be good for you to select some of the research topics. Next slide, please. Next. Shivam, next. Hello, Shivam. Go to the next slide. Am I audible? Am I audible? Am I audible, Shivam?
Yes, ma'am.
I told you to change the screen.
Just ma'am.
You can stop the recording.
Now it
Now
okay.
now I hope you can start from the
Yes, ma'am.
slideshow. You can start the slideshow. Previously, it was not there.
Is it okay, ma'am?
I cannot see the slideshow. It's okay. I can see this. Go to the next slide. I can see only first slide. Yes. Can everybody see the next slide? Okay. Previously, I think I was not clear to all of you. It was not audible. Is this audible now?
Yes.
Okay, good. So let's start with this. These are the contents which I'm going to take up, some in brief and some in detail. And in the end of the contents, I'll be giving you the idea of the Indian microgrids, the microgrids which are already established in some parts of India. So that will be my presentation, or that will be my lecture, or that will be the content. You can say the introduction to conventional grid, smart grid, and microgrid. By now, these are the three hot cakes that how we can compare the smart grid or microgrid with conventional grid. What are the benefits? What are the effect? What are the causes? Those things are people are doing research in this area. Then what is exactly microgrid? A brief introduction of microgrid, then the classification, and then I'll come to the topic of the lecture, that is economic benefits, and in the end I'll take up the Indian microgrids. Okay, next slide please. So in the traditional power grid, which you already know that it has a centralized generation, then long transmission lines, higher transmission losses, and it covers large geographical area and handling high power, that is hundreds of megawatts or gigawatts, one way information flow and power flow, more blockouts, because the centralized activity for such a large country or such a large space difficult to manage. So sometimes we have the blockouts also, and then you have to take care of it. So poor quality, we are getting poor quality of the supply. So this is known. Next slide please. When we go for a smart grid, we should know about the communication, advancement in the communication. So it should be automated fault management, then the dynamic pricing mechanism. Because if I'm using a good quality power, then I should pay for it. Or if I'm not using that, so I may get the economic or cheap power. So that kind of thing I can get, and this management of getting power quality should be in my hand. So that is a smart grid. So if you want to do the research in a smart grid, then it should be a combination of information technology, computers, and the knowledge of power system. So then you can go for this. People are working in this area also. And the application of advanced technology for household electricity uses, track and manage. So the control will be what supply you are using, what type of supply you're using, that will be in your hands. Next slide, please. Now we come to the microgrid. Two types of grid we have been discussing. One is conventional. People have done so many research in the conventional grid also. Still the research is going on in some of the areas of conventional grid. Say flexible AC transmission. People are doing research in that area because it's a big structure. Then the smart grid, when we want to, actually we want to get everything very fast. Whenever there is a problem, it should be cured very fast. So that way the smart grid is there. And the third is, which is known for this FDP, that is microgrid. In microgrid, so many sources, so many consumers, so many prosumers, and they are together, they are giving some benefit to the electricity consumers and the system, total system. So this microgrid can be defined at at a different levels, that interconnected sources of distributed energy sources. It can be wind, it can be solar, it can be biogas. So if they are assembled together, and then there is a control unit to provide the electricity to various utilities, then it is a microgrid. It can be in islanding mode, it can be connected with the grid also. So these are the things well known to all the electrical engineers. Then next slide, please. Next slide. Go to the next slide. Yes. This is another type, another structure. One structure you have seen in the previous slide. In this particular structure, we can see that in this structure, we can see that there is a microgrid. Then there is a, it can be connected to the grid. It can be disconnected from the grid. So there is a on-off switch with the conventional grid. Then we can assemble so many solar source, battery source, then wind source, then these vehicles also have battery. So this is another kind of battery source. It can be charged or it can give the power to the system. So this is one diagram. Another diagram you can see here, that the microgrid can be community microgrid. If a small microgrid is connected in a community, then it will supply power to that particular community. Then it can be utility microgrid. So different types of name can be given to the microgrids depending upon a particular area. Okay, so this has a big flexibility. It can be of small size, it can be of slightly larger size, it can be connected to the grid, or it can be off grid. Next slide, please. Microgrid has so many advantages. Um, Not require explicit communication links for safe, stable operation. So because the communication links are small, so very high or sophisticated type of communication is not required. Then operational decisions are made locally based on immediately available measured information and programmed set programs points, increasing the robustness of the microgrid. It is a well-known fact. If a system is small, then it is easy to control. So if you are supplying the power to a particular community, and if you are receiving the power from nearby areas, then it reduces the complexity. This is the first advantage of microgrid. Then another advantage of microgrid, that all sources act as peer voltage sources. Okay, so no single source is designed as the lead. So if it is shared by so many sources, then the weight of the supplying power will on a particular source will not be much. So it's a distributed source, you can say. Then further, will all sources acting as peer voltage sources, no complex mode changes are necessary when transitioning to or from the larger microgrid. Next slide, please. Next. Yes. So the third major advantage of microgrid is the separation and resynchronization to the larger grid is automatic. So you can say that uh, requiring no user intervention and occurs in a seamless fashion. That is advantage of the microgrid. Then utility interconnection requirements are also satisfied at points of common coupling. PCC you must be hearing. Then instead of each source location, this reduces utility compliances concern and proof testing while reducing integration costs. Whenever the system is small, the rating is also small, so it reduces the system cost also. Next slide, please. As far as characteristic of the microgrid is concerned, it has own internal control, and optimization strategy. Shivam, it's not in coordination with the slides. Go back. I was here only. So this characteristic of the microgrid, it has own internal control and optimization strategy. Then it can be islanded and connected with minimal service disruptions. So if you can use it, it means that you can use your microgrid for a particular building also, for a particular community also, for a particular institute also, or you can say industry also. You can have separate microgrids also for a campus. So that way you can reduce the in islanding mode in a different locality. So that way it can be used, and it provides the flexibility. Then the application to various voltage levels, that is also possible, and then it also has the storage capacity. Next slide please. Now, as I told you just now, the classification can be further extended. Previous slide. This is remote microgrids. This, instead of off-grid microgrids, no access to grid, operates in islanding mode. That is called remote microgrid. Then grid connected microgrids, as I told you just now. Then networked microgrids. This is a new concept that different microgrids are connected together. They are working, as I told you just now. Next slide. This is the Indian scenario of electricity. Here the peak load is fluctuating. As in other countries, same is the scenario, but our load flow estimation is not very close to the reality. So we should think about microgrids. Whenever there is a peak load shaving, that can be done with the help of microgrids. Next slide. This is just the repetition that to meet the electricity energy imbalance, to improve grid resiliency, power quality, resiliency pe so many people are working in the grid resiliency, to avoid power cut and to reduce the losses. These are general standard reasons. Next slide, please. Next slide. Yes. Deployment consideration for microgrid. Suppose I want to install a microgrid, what are the considerations I should take? The analysis of government policies. This is financial and economic analysis. So it's not like that just you put the microgrid and have the sources and start using your microgrid. You should be aware of the government policies that analyzing the resources. You might have heard the name of Homer software. It's quite successful in finding the renewable energy sources in a particular environment. So with the help of that, the analysis of the renewable energy sources can be done. Then the demand. What is the demand? That should be known to you. And slowly then you can have the different assessments, uh, then the management policies, then grid availability. Suppose you want to install your microgrid in a remote area, then is this possible to have grid there, main grid, or it used to be there, or in future it is not going to come there? So these are the things you have to check, because power demand is always increased. So suppose 20 houses are there, in due course of time, in future, maybe 10 to 20 years, those houses may be 20 or 50. So you have to plan accordingly. A small microgrid will not be enough to supply power to all, and there is no grid. So that way you have to manage your policies. So these are the deployment consideration for microgrid. There are so many other deployment considerations also, but these are the major deployment consideration of microgrid. So one should know about all these things. Next slide. Now, what are the benefits? As I have been discussing right now, that the benefits are economical. When one example here I can give you, if you want to take the grocery from a nearby shop, it will be very easy for you. And if it is a small shop, then selecting the material will be easy for you. Communication charges will be less, your time will be less. So in similar manner, the microgrid will also have some benefits. One is economical, other is environmental. As I told you that so many environmental energy sources can be used. So it will be a green energy. So microgrids, another benefit is environmental. And third is technical and resiliency, because if it is a small unit, then technical awareness is good, replacement is good, financial involvement in this replacement of the component is also good, and it will always be resilient because it's not a complex system. So these are the major benefits of microgrid. Next slide. Now it can be shown in this manner also. It is another way of presenting the benefits of microgrid. How many utilities are there? Voltage regulation can be done, peak load shaving can be done, then energy loss can be reduced. So this is another way of showing the benefits of microgrid. Next slide, please. Now the benefits, net microgrid benefits can be defined. First is economic benefit, reliability benefit, then environmental benefit, then deferred transmission and distribution benefits, then additional generation and construction. Because microgrid is a small construction, so very large equipments or very large construction or expensive construction is not required. Next slide. Now we can just concentrate on economic benefits again, because the time of this lecture or this content is to give you an exposure of the economic and the environment benefit of the microgrid. So I'll again come back to economic benefits. So economic benefit, first part goes to the consumer benefit. So microgrid dynamic pricing software calculates in real time the lowest cost source of energy to the consumer. What does it mean? That when the limited number of consumers are there, so it becomes easy. So you should, if you know some software, some pricing software, you can easily calculate in real time. You can take the data, from the community, and you can easily do that. Suppose you want to do the research on a particular area, you can select so many different areas from your nearby community. So many papers have been published in um, this type of papers are published. They consider one building or they consider one community, and then they try to find out with the help of solar energy or green energy parameters that how it will work. So it's easy for the researcher to do. Then the either the main grid or local generation sources, rooftop photovoltaic panel or wind farm integrated to the microgrid. Now suppose somewhere only PV is available, and you have to make your microgrid with the help of PV only. So it becomes easy for you. Suppose you go for a wider range, then suppose wind energy is also available, PV is also available, then you have to integrate these two. So it becomes slightly complicated, but in some places the abundant wind energy is available, so a small part of PV can be used or it can be neglected. So that kind of thing will give you economic benefits. Next slide. Another is DER benefits. Many countries have introduced incentives to implement renewable energy. Then it includes the subsidized price for the owner for a renewable energy generation, PV, wind, etc. So it's a policy type of benefit. Next slide. Next slide. Then grid is no back one. Previous slide, please. Grid spending reduction in areas where the existing infrastructure is under high demand, where there is no existing electrical infrastructure in rural areas. So as I was telling you that in remote areas you can easily have this. Then microgrid implementation could represent a much cheaper alternative to transmission infrastructure cost. You must be knowing that in coal generation, where the coal is generated and where you get the through the transmission where you get the power, it increases. Say if it is 2 rupees at the generating at, it will be maybe around 10 rupees at the other end. So the 8 rupees is because of the transmission costs, etc. It's not a standard example. Somewhere it is different, but cost at the receiving end is very high. So you can reduce that. Then network spending um, is in that respect reduced at the very least for, and it can be handled that way. Next slide, please. Now, coming to the research point of view, how the economic issues in microgrid can be are developed in India. One is the optimal mix of resources. Then the optimization techniques will help you to do that. Then power quality and reliability maintenance. Then optimization of heat and electricity, then metering arrangement, connection mechanism, tariff mechanism. Although you can see 6 points or 6 economical issues, every economical issues has several research papers. You can select one and you can work on that. Say for example, the metering arrangement. There are smart meters, you can work in smart meters and you can show that it reduces the cost. Then connection, the restructuring, etc. Those things, the connection mechanism can be proposed. Then tariff mechanism is, say, energy saving in peak load time. You suppose I can take a one example, say the office time. Office time, all the cars are going to the office and all the cars are electric vehicles, you can say, are on the road. Then they are on the charging station. So many cars at the charging station, so they'll supply the power to the system. So the battery used in charging the car can be used for that system. Next hour, when the cars are required, then it can be taken back. It is done in so many advanced countries, but in India I don't think we are able to do that, but it can be done. But if you are doing research in India, then you can go for power quality, reliability, maintenance, optimization. Those things can be easily done. Data are easily available in this area. So these are the economic issues in microgrid development. Next slide. Then cost criteria. Of course, when we go for economic, the cost criteria are very, very important. Some of the cost criteria are well known. Some of the cost criteria are directly related to the microgrid. If if you have the conventional grid, even if you go for thermal, you go for hydro, the installation cost is important. Similarly, in microgrid also, the installation cost is important. So uh, what is the installed capacity on which it depends, then composition of capacity, then installation cost, then operational cost, then maintenance cost, yeah, running cost, you can say. The cost of the microgrid depends on the size and complexity of the system. So there is nothing new. The cost criteria of the microgrid is just like the cost criteria of the another system. So, but of course, if you compare it with the conventional grid, you will see that minor items will help you to reduce the cost. Okay. Then additional control system. Control system, again, I'm repeating that if it is a complex system, the control system will increase the cost. Okay. So this is not the case in microgrids. You can have very you can also relate it justified cost. So next slide. Now, how you can calculate it? This is a standard way of calculating it. This slide is taken from a research paper that capital and installation cost, then ACAP, then AREP replacement cost, then M is maintenance cost, SAL is salvage cost, and F is operational cost. So you can add for solar, for wind, for battery, for biogas, for inverter. So you can add this way, or you can deduct. So those things uh, uh, you can patronize. Next slide, please. Now, normally we hear this word levelized cost of electricity, normally used for the um, renewable energy sources. So measurement, how it is done. This definition of this is sum of cost over lifetime and sum of electrical energy produced over lifetime. So first you have to decide the lifetime. What is the lifetime? In solar panels, we normally call it 25 years. So here it can be mm, that way how much it will produce. So levelized cost of electricity, this word is very important. Normally a question are asked in this area that what is levelized cost of electricity? The formula is given here. Next slide. Then PV system localized cost. This levelized cost. How it can be calculated? Cost of capital, system life, residue value, plant energy production, annual operational and maintenance. PV solar may very less maintenance cost is there than PV plant cost. So these are some of the parameters on the basis of this cost is calculated. Next slide, please. Now PV plant capital cost, how it can be calculated. So we are slightly going into deep how we are calculating it. So the financing, who is going to finance? Suppose I take a financing agency, then I have to give the interest also. So that is there. Then equity cost, debt cost, project leverage, those things I have to see. Maybe as engineer you may not be able to understand. You can call somebody or you can give it to somebody, some account person, please calculate this. Without that, because when you are dealing with a certain limited amount of uh, uh, cost or certain limited amount of capital, then you have to manage with the pi to pi, right? So then another point is predictability of cash flow, then performance risk and weather risk. Now, as everybody knows about it, but we have to consider this parameter that wind, solar, they depend on the weather conditions also. So you have to take care of that risk and that cost. Next slide. Now PV plant installation cost. PV plant installation cost में development cost, site specific cost, then PV basic plant cost are important. If you further go for it, suppose you want to plant your PV in particular institute, then people will start saying how much area you want, where you want, this building should not be destroyed. So those kind of thing we have also faced in NIT campus, that it can be installed in a particular building, it cannot be installed because this structure is quite slightly heavier, or because of some other reasons in some buildings we cannot use that. So that has to be seen, that development cost, suppose it is somewhere else in some place where you cannot clean it or where you can go, so then again it is a problem. So site specific costs are there. Sometimes you have to purchase the site, purchase the land, so site specific cost is there. Then PV basic plant cost, PV power block, then balance of plant, designing, commissioning, project management, indirect cost, mounting, converters. As I heard about it, that in PV plant, the most uh, uh, costly part is converter. If you have a sophisticated converter, then this installation is going to be very expensive. But It will improve the resiliency, it will improve the power quality also. So normally in homes, we go for a medium size inverters, but in um, big installation, we have very good inverters, although it increases the cost. Next slide, please. Now, PV plant production cost. So we have the installation cost, we have the commissioning cost, we have the production cost. Production cost may we have the system performance, then local climate. So these are all general criteria, but modeling with these criteria is very difficult. So this is what people are doing, that to take these criteria along with the system and then model it and then find out the cost is a challenge. Then the system performance, module performance, degradation, high temperature, low light performance, then electrical system efficiency, system availability, soiling, mounting system, etc. Then solar radiation. These are the things, these are the factors one has to consider. Then local climate also. Next slide, please. Then operational and maintenance cost. The panel cleaning, solar mates, it's a very less, but it is there. Then site security. Suppose there is a building which is a which is not very high building, and you have installed the solar panel on that particular building. Now suppose high building is coming in future nearby, and you will have the shade on the solar panel. These shades on the solar panel will reduce the capacity, so that you have to see. So that is operational and maintenance cost, that in future also you should get that amount of solar radiation. So then financial reporting, taxes, insurance, etc. Land issues. Next slide. Now solar tariff in India, as the technology improves, the solar tariff, or so many vendors came into manufacturing this solar PV, so it reduces. Next slide. Then the solar tariff and PV installed capacity is increased in last few years. You can find the data from the websites also, that increased quite a lot. In India, you will find that the PV capacity we have reached to the 2030 limit. So I was just going through the MNRE site, that we have already crossed that limit, which we have decided to have by 2030. Okay, so it means people are doing research in this area, and people are using this solar PV. It's a good sign in the area of environmental energy study. Next slide. This is component-wise cost of solar plant for the different components. So because it's a very small size of slide, I cannot read it. But later on, you can take the PPT from Shivam, and it is also, I think it is recorded. So you can see if you want to check the which component has how much cost. Whenever we estimate the cost, we have to see various factors where you can reduce the cost. In some places, you cannot reduce the cost, but in some important places, without compromising the reliability, you can reduce the cost. You have to see the market also, because so many vendors are coming. Sometimes when you are thinking to uh, analyze the cost, the particular component is very costly, but by the end of the year, or maybe after 2-3 years, when your PhD is complete, vendors may be providing that particular component in a very cheap component. So that way it always fluctuates. So this gives some idea of it. Next slide, please. Now it is the solar tariff in different states, as in 2017. It's a different solar. You can see, this is important point, that the solar tariff is different in different areas. Why it is so? Because of the solar radiation, because of the available of the sources. So it's a different. Okay, I cannot read it now from the slide. Next slide, please. The batteries cost over the year. The important parameter of solar PV generation is batteries. So because so many people are working in the battery area, so it is also reduced. As I was telling you just now, that one component may be very less during your course of study. So you have to see that also. Next slide. This is another pattern of battery cost. It is reduced because there are different types of batteries. So in particular cases, the battery which we lithium ion battery is normally used, so its cost is reduced. It can be um, it can be implemented easily. It has so many advantages. Also, people are doing research in the battery area also. Next slide. Now, levelized cost of storage. This slide is directly related to the battery. How to find out the levelized cost of storage. Next slide. Now, first part is that economic benefit, how we can find out and what are the criteria we should see. Then the second part of the this lecture is the economic benefit. We know all the economic benefit. Let's discuss it again. That greenhouse gas reduction, microgrid most generation from local renewable energy sources. Local energy sources drastically reduce the electrical losses incurred in the on the grid. Combined effect translated into CO2 emission reduction. Now people are talking about the zero net. So those are the new topics coming up. Next, net zero बोलते हैं इसको. Next slide, please. This is technical benefit. In the previous slide, general benefits we were talking. Peak load shaving can be easily done. Environmental greenhouse effect is there. Technical benefit is that you can get the resiliency, you can get the continuous power. Next slide. Then power quality can be improved. The voltage regulation will be better. Then control and automation solution are also can also be provided easily. Next slide, please. Then loss reduction. Without loss reduction, there is no engineering system can be made. So local generation reduces the need to transmit in electricity across the grid. So thus the losses, electricity losses are less. Next, these are technical benefits. Then reliability enhanced because of the less complexity and the system becomes stable. So it increases the reliability. Next slide. Now this is the list of Indian microgrids. As I was telling you, so many things, so many criteria, and in different lectures people are telling you. But in existence, what are the plants we have in India? You can see, you can have a glimpse of these Indian microgrids that the capacity of 26 kilowatt. What is 26 kilowatt? Nothing. But people are having that microgrid. Then 500 kV system, then 260 kV decentralized energy systems of India, then husk power system. So if they are the generating sources biomass in two of the cases which you can see here, if any Indian microgrid is close by, then you can go and you can find out the data, you can get the data, you can do the research. So that way, this slide will be helpful to you. Then Uttar Pradesh Navant Renewable Energy Development Agency, they also have in 27 district with capacity of 1.2 kilowatts. Next slide, please. There are 250 kilowatt, all are microgrids, 8 kilowatt, 500 kilowatts. So there are so many. Next slide. Next slide, please. Then this is Kargil location, far off the remote area. They also have the solar microgrid in Ladakh. So remote and inaccessible village in Ladakh, they have the 1 megawatt aggregate capacity, right? Then 3.5 million units of power has been generated in first 2 years, including schools, etc., school and institutions. So these data are very helpful for you if you are working in this area. Next slide. The Sundarbans. This is the West Bengal. This is another remote area. One is hilly area, another is Sundarban. So there we have 110 kilowatt solar microgrid, taking 90 minutes ferry ride from Pathapuram Ma to Indrapuram in Sundarbans. Day-to-day activities in very limited uh, sunlight with almost next to none grid connected homes. So that kind of problems were there. There the microgrid, solar microgrid was installed. Next. So these are the different types of Indian microgrids. In Chhattisgarh also we have about 100 solar microgrids. Next slide. Then in Ladakh, that was in um, previously the one we have mentioned, Ladakh. Then another one is that is coming 35 kilowatt solar microgrid in some other area of the Ladakh is also coming up. Next slide, please. This is Karnataka and in Delhi. In Karnataka, school saves up to 4,000 on monthly bills with rooftop solar by Marcom India. In even in NIT, we save monthly bill. I think uh, 10 lakhs we are saving. So that way we have 1 megawatt solar panel, but it's not microgrid. It's connected to the grid. So if you have microgrid, you can save energy also, and these are the live examples. Next, these are some of the industrial microgrids, and ABB has made it. Then power store battery rating this much. Then lowering the this one lower the carbon emission also, because whenever any system nowadays are we are making, we have to show that the carbon emission is very less, otherwise there is no point of talking about green energy and all that. Next, the Lakshmipura, Jahira, and Rajasthan, they are the so many case studies are there for a small um, group of families, that is number 22 families, total population around 100, major source of income farming and labor works. So before solar, microgrid basic source kerosene, wood fuel, these are the solar lantern, etc. If they have a small microgrid, 2 kV solar microgrid is installed, and they are getting the television, they are getting the fans, solar, and they are getting the supply. They may also get the internet facility, etc. So it is also helping the small community. Next slide, please. Then the microgrid case study is Lakshmipura, Jhalra, Rajasthan, right? So many examples are there. You can go, you can see, you can find out the data, and then you can make your own project. So if you do this, your research will be appreciated by so many good publishers also, and you can publish your paper. Because in power system, we face only two things. One is availability of the data, and second thing, though the data is with some persons, they don't like to give. So you can rule out. If it is a small unit, you can easily do that. Okay, next slide. This is another Jhalra, Rajasthan. These are the advantages, general advantages are there. Students can study at night, etc. Next slide. The comparison of grid connected solar homes and microgrids. Reliability, characteristic is reliability and power quality. Then cost of generation for producers. So grid connected individual solar homes and microgrid system. So microgrid system had so many advantages. We have been discussing those advantages. Next slide, please. Price of electricity for consumers, then load capacity, then losses. So you see that microgrid system is having the better system, and these are the advantages. Next, the generation sources, geographic and local based constraints, and the operation and maintenance is also less. Next slide. So Indian scenario of microgrid, you can see that these are the places where the microgrid is operating. If you do research in microgrid and you get the data, more number of microgrids can be installed, but optimization is very important, and those are the criteria which I told you should be incorporated. Next. So this is initiation and policies by the government, because so many microgrids are already into picture. So these are some of the schemes: Rajiv Gandhi Gram Vidyutikaran Yojana, then Deen Dayal Upadhyay Gram Jyoti Yojana. One of my PhD students used to take the data from this Deen Dayal Upadhyay Gram Jyoti Yojana, then Pradhan Mantri Kisan Urja. This last one is, I think, within last few years they had come into picture. Next slide, please. This is microgrid around the world. Just to give you an example that people are using in the world also, or not only in India. Okay. Next slide, please. Then, as I told you earlier also, that Homer software is helpful in finding out the environmental condition. It also calculates the cost. Now, this Homer software is made by the, I think, some American or some other country. So it doesn't suit in our environment, but it is quite helpful to do the research. So many people are doing research using Homer software. बहुत सारी, there are so many properties are there. It gives you the cost also. It gives you the environmental condition also. So those things it can give you. But you can go on your own also to find out some of the data. Next slide, please. So these are the references from where me and my research scholars have collected these data to give you in this FDP. And thanks to Shekhar Charan, who helped me to find out various scenarios. Thank you, everybody. And I hope it will be a bit helpful to you in doing research. Some of the areas I have shown, but not a particular research I have shown to you. If you find out any specific paper from these research references, you can find out the specific papers also, and then you can go for the research in this area. I think so many areas are there to explore still. Okay, thank you.
Thank you, ma'am. Thank you so much, ma'am. So just I want to introduce
Participants.
Yes,
Yes, please.
So
yes, please.
yes,
Glad to
participant, directly you can ask here. So, ma'am, are you seeing? These are.
Yes, I can see everybody here.
Yes, yes, ma'am. So, yes, he, ma'am, he is from Kurukshetra University.
Good morning. Good morning.
Yes.
Yes, you are from which place?
Ma'am, UIT Kurukshetra University.
Okay.
Ma'am, you are student in BS.
Yeah, I was trying to recognize you. And who are I think some of you are sitting there. Please introduce yourself.
Yeah.
Good morning, ma'am. My name is
Good morning.
my name is Vincent, and I'm undertaking MTech in Kurukshetra University, and Dr. Vijay is my guide. So we'll be available.
Okay, good. It's quite cold there, eh?
Yes,
Everybody
yes.
is wrapped up with the woolen clothes.
Good morning, ma'am. My name is
Good
Bob.
morning.
I'm from Department of Instrumentation. Yes, I'm an MTech student. Thank you.
Okay, good.
If you have any query, you can ask me. Yes.
Good morning, ma'am.
Good morning.
My name is Ibrahim. I'm from Electrical Department. Dr. Vijay is my supervisor. So,
Okay, good. Good.
okay, thank you.
Okay.
If you have any query, you can ask directly to ma'am.
I hope you must be doing some work in this area, because when you have opted for this FDP, so you must be interested. And there are so many areas. I have not touched a particular area in my lecture. Anyway, if you have any query, you can ask me later also. You can send any question
Ma'am,
to
there
my
is,
email,
ma'am,
and
there,
then
there is
we
one
can
faculty.
discuss those
Yes,
things.
ma'am. For interrupting you,
And,
ma'am.
I hope you are happy with the course contents, and we have very good labs also. Dr. Shivam will be showing you the labs. I don't know whether their son is there. You can see the rooftop lab. We have very good rooftop lab here for solar thermal experiments. Vikrant is doing PhD in this area, so you can ask him. Then we have very good lab in microgrid also. Simulation studies can be done there. So I hope your stay will be good. All the best. Thank you.
Thank you, ma'am.
Thank you, Shivam, for giving me this opportunity. Okay.
Thank you so much, ma'am. Thank you.
Leave now, Shivam.
Now I am going
Okay.
to continue, ma'am.
Okay, thank you.
Yes, ma'am. Good morning. Is it audible?
Yes, yes.
Okay. So, Professor Ratna already discussed about the microgrid. Yes, very placed. Yes. So all industry based on the microgrid we have seen. Ma'am has already summarized where are the microgrid right now. So in our country, microgrid is running. So we should know this first. And later we want to describe where is the problem. Yes, where is the some hidden problem? Because if you are going to see the research paper, they will not show. Yes, only show the what are they wanting and what they are going to achieve. Yes, in the conclusion they can they highlight it, but they didn't mention what are the limitations. So we have to search with the help of various what we can say journals. Yes, they can then we can define yes there is a some problem. Yes. So this is the topic which I share with the ma'am, and first part ma'am we covered. So this is the second part of this session. So topic is power quality means DC micro. Yes, power quality is DC. So then okay. Yes, now it's okay. So these are the key points basically we are going to I am going to cover here. So I'm not going to invest time where you already did it. Yes. So this is the basic microgrid. Yes, you already this seen in various natures, online and offline. So I'm not going to wait here. Yes. So try to give some time here. What is why we require microgrid? Yes. So we know that there is the energy connection. Otherwise, we cannot move for any microgrid or nanogrid. Is it not? If you want to move microgrid and nanogrid, yes, or a hybrid microgrid, obviously there is required something. Yes, because if we are not going to lack something, we don't want anything. So where is the lacking? So one point is energy crisis. Yes, transmission losses. Transmission losses. See, day by day energy demand is going to increase. So we want to generate more energy, and we also use this conventional energy awareness also limited. So we are going to search renewable energy source, and there is also some constraint. What are the constraint? Area is also required, because if you don't have area, if you don't have a space, you cannot install PV system. Yes, right now in the last day, that means yesterday, you have seen lab session where microgrid PV system we already installed. On the roof, you have seen various lab experiments. So in that way, we can see if you want to install PV system, there should be area. There should be area available. Otherwise, we cannot install more PV systems. Yes, so there is one question. That is the area. Yes. And in that way, if you see, if you want to observe, that one is the transmission. Yes. So somehow we are going to compromise, or not compromise, we have reduced transmission losses in case of the hybrid or microgrid. Yes. Otherwise, we cannot implement microgrid. So there is one advantage behind microgrid, that is to reduce transmission loss. Okay. And second point, third point is it results in substantial saving network emission without major change in lifestyle. Provide high quality and reliable energy supply to critical loads. Yeah. So right now we can see loads are also classified. Yes, we cannot read all loads in the same platform. On the same platform, we cannot see. Some loads are critical, some loads may be managed. So in that way, loads can be forecast. Yes. So for critical load, we have to have reliable powers. For that, when microgrid also come on the picture. Yes. And microgrid ensures the use of renewable energy sources. Why this? Because all renewable energy sources except wind energy, that is a local. We can manage this. Yes, at the small scale we can manage this. Okay. And CO2 emission also reduce. We know this. Large land impacts are avoided. Obviously, if you are going to implement conventional, then we can say locally we are going to make microgrid. In that way, we are going to reduce large land. Okay. So this is the basic observation, basic benchmark. Yes, behind microgrid, voltage and frequency variation. We cannot compromise. If there is some variation, we cannot compromise. Yes, and poor load sharing. Yes, what is the load sharing? We will discuss proper sequence way in next slide, upcoming slide. And microgrid resynchronization with the main. This is the always become challenge. Either you can see conventional grid or you can see microgrid. Resynchronization problem is always there. So for that, whatever conventional methods we have to follow and we have to modify capacity. Yes. Now power flow control with microgrid mainly. This is also important. Otherwise, we cannot say we have utilized power efficiently. Yes. So we are here for microgrid. We are here for renewable resources, and we know that under renewable energy sources, PV is the main person who is giving the power. And we know that we are going to we want to extract power by MPPT. But behind the MPPT, there is some objective. Yes, if your load are not sufficient according to the generation, we are not able to work on MPPT. Yes, so load should be there. If load is insufficient, then we have to have grid connection. Otherwise, we cannot extract maximum power. So right now there is a smart meter, and by which we can fill the power. Yes, if you have an installed PV system, and you know this the power flow control. Yes, in that way you can send power to the grid. Yes. Next one is optimization of microgrid operating cost. Yes. So this is the basic hybrid microgrid. Yes. There is DC microgrid as well as DC microgrid, and these two grids are interconnected. So if you are going to see power quality, we have to have basic parameters. It should be fulfilled. That means frequency should be should be controlled within the permissible limit. Yes, that value is already given 0.005%. If you are in DC side, there is also a specified voltage variation. Yes, so voltage variation, frequency variation. Yes, obviously these two parameters depends upon the power. Yes, suppose input last session, that is the last session, we have seen in the microgrid operation. Yes, if you remember this, in the islanding mode, we cannot start until unless we don't have this high load. Yes, if we have more than load compared to source, we cannot operate islanding mode. Yes, so we should be aware behind the load in case of islanding mode. Yes, so loading load setting is also important. Yes. Next. So these are the basic arrangement behind the microgrid. Yes. Right now we are discussing the microgrid. If you are going to say there are many microgrids available, how to manage this? Obviously, there should be required one control system which are going to manage all that. Yes, how it manage? Obviously, it is going to with the help of transmitter. Yes, so this is the one of type of control head. Yes, so starting from lower primary control scheme. Yes, primary control level. Yes, next secondary control level, and last one is the tertiary. Yes, so tertiary control level. Obviously, it is going to monitor between the among the microgrid. So, if you see in under tertiary control, yes, you see under tertiary control, optimal operation in both operating. Optimal operation both operating means what? Both operating mode means either it is connected with the grid to microgrid, or it is going to connect with the yes. And second one is the power flow control grid, right? Yes. So these 2 points are going to control with the help of transmission. Apart from this, we have to see secondary control. Secondary control is nothing but it is going to control microgrid. Yes, under microgrid there are more than 2 or 3 sources. Yes, all are going to give supply. Yes, in proper. Yes, see there are big challenge. If you are not going to control properly, we cannot extract power from all sources at the same time. Yes, if you are not going to control means what? That means power is supplying from the source, but it is not going to stay effective power. Yes, effective power saving is what? Suppose one source has capacity 100 watt, another source has capacity also 100 watt. But what practically what we are going to see due to unbalanced line impedance, what we are going to see, both sources are not giving equal power to the common load. Yes, why this? Because there is unequal parameters. Yes, unequal parameter means what? One has cable resistance due to installed distance from the load, and another one has also some different distance. Therefore, cable resistance are different. Yes, and we know that both are placed at near locally placed. Therefore, we can say for both sun irradiation are same. Yes, and if capacity, installed capacity are same, that means both solar system can generate same power. Yes, but practically it is not going to generate, or we can say we are going to extract power, equal power from both sources. Reason is both cable line impedance are different. Yes. So suppose one cable line resistance is 1 ohm, another one has 2 ohm resistance. So can we say how much power is going to extract from one source and how much power we can extract from second source? Suppose 100 watt and another one also has 100 watt, load each connected for 200 watt. We cannot say that this is going to share by the 100. Yes, it cannot be seen. If it is going to happen like this, then we can say there is the effective power there. But due to unbalanced cable impedance, yes, unequal power share will be. Yes, so we can say we are not capable to take equal power. Yes, so that is the lagging behind macro. So we have to work. We can so many researchers have already worked. Yes, they have implemented many controllers. Yes, to make effective power. Yes, and for that they have already given many controllers. But thing is that what new controller scheme can be implemented by the new researcher, depends upon the linkage. Yes, so there are various controller schemes, but there are also various linkages. So if you are able to read literature proper way, then we can easily identify this, which one has which type of linkage. Yes, no one controller scheme claims that this is the this controller scheme is going to fulfill every linkage. All linkages cannot say that. Why? Why this? Why this? Because there are various issues. If someone is saying that this controller scheme is more reliable, it means there is implemented more costly system. Yes. So there we can say that this controller scheme is more costly or more complex compared to others. Yes. So somehow we can see limitation and we can overcome with the help of new control. In that way, we can publish new control. Yes. So next point, our primary control. Yes. So the primary control we can see here. Primary control, voltage stability, frequency stability. Yes. This is the primary control. Because one source is connected to the microgrid, there is a specified. This should be the voltage, this should be the frequency, and this source should be generated according to. Yes. If all sources are going to generate own way, we cannot handle it. Yes. So secondary control level is going to have manage all primary controls. Yes. So we will see one work here, and in that way we can conclude. Yes. So if you see the coordinated controller scheme, yes, microgrid controller scheme, it is or we can say second controller scheme at secondary control level. Yes, that means secondary control level. This secondary control level had mainly 3 types. Yes, one we can say centralized control. Yes, centralized control means there is some control unit. Yes, central control unit, and it is going to connect it with the communication line with all sources. Yes, so some input parameters are going to select or read by the central control unit, and after making some control algorithm, it will send to the all local control. And in that way, voltage and frequency are controlled at the common lines. Yes. So, in the centralized control, obviously there is central control unit and network. Yes. Now, our question, apart from this central control unit, there are more two controlling a scheme. Yes, different type of control. That one is the decentralized and distributed. But thing is that why these two controllers being developed due to limitation of control, central controllers. In the central controller thing, what are the limitations? One is communication link. So communication link is the disadvantage. How? Because if you are going to use communication link, due to some reason, there is some fault, there is some misconnection, due to that, your whole system will be affected. In that way, we can say this control system is centralized control scheme is not going to provide reliable system. Yes. So this is the limitation. Second one is there is a central control scheme. Yes. If you are going to see in the decentralized control scheme, there is no central control scheme. Yes. So how it is developed? Obviously, it comes after studying centralized control. Centralized control. Yes. So, if you are going to propose something, yes, if there is some complexity, if there is some issue behind the reliability, yes, it means there is an open for new concepts. Yes. So if you are going to study the literature, if you are going to see some new paper, try to see, yes, what is the limitation. If you are able to see limitation, immediately you can able to generate new idea, by which you can able to publish. So this is the basic concept behind making meaning. So our main objective is to see not only advantages of the paper of the proposed control scheme, but also aim is to search what is the limitation. Yes, and many research papers don't want to show all limitations. Why? Because they want to research. Yes, if they will show the limitation, they cannot do new research. Is it not? So this is a small window, and we try to yes. So this is the key point. Yes. Next, we are going to see some work here. Okay. So this is the one block diagram. Yes, this is the one block diagram where where are these sources. Yes, and we are going to discuss the DC microgrid. Yes, DC microgrid or distributed control. Yes, so we are going to see. Before that, we can see here we have mentioned cable line impedance also. Yes, I have done this work nearly 2018 on this. Yes, but thing is that this work already done during 2013 or 2014. Yes, but I have already also published something. Why? Because I found the limitation. Yes, and with the help of their limitation, I have highlighted the advantage of. Yes. So try to see first limitation of the. So similarly, I have taken here the distributed control scheme. Yes, there is a common load. Yes, and three cable line impedance, unequal cable line impedance. Yes, and objective is what are the objective? Same objective, which are going to covered by other researcher during 2013 and 2014. Same objective I am going to carry, but why is that? What we are going to take difference? Their linkage. What is the limitation? They have taken same distributed controller scheme. I am also going to consider distributed controller scheme. There is a difference on behind controls. Their controller scheme somewhat complex. In which way? Because they have taken cascaded layer. Yes, if they have taken cascaded layer controller, it means what? Obviously, there is required to tune PI parameter. If you are going to use single PI controller, easily you can tune. But if you are going to use PI controller in cascaded way, there is some complex to tune this. What is the limitation? There is a limitation. Yes, you can generate or you can propose new controller key by which you can make less complex control. Yes, so same thing I have. Yes, so we will see. So before starting a controller scheme, try to see the objective. What are the objectives? First one is to make effective equal power saving. Effective equal power saving is what? Because you cannot claim the equal power. Practically, we cannot see. How? Because we are sensing voltage, we are sensing current. Here is the instrument. Yes, and there is also cable impedance, cable resistance, and these parameters are going to change due to the temperature. Yes, still we can say there is some instrument cannot be claimed that whatever sensing that is accurate. Sensing parameter is also not accurate. Yes, therefore we cannot claim that effective equal power. Yes, we can say effective equal power. Effective means almost we have. So this word is a technical word by which we can we will save. Otherwise, someone claims this. How do you claim this? Equal power save. Yes, if temperature is going to vary, your cable line resistance will vary. How do you measure this? At that time, you cannot defend this was yes. So we should use word in the same. Yes, effective equal power. Yes. So this is the objective, and that is the one. Another point is some power is going to circulate among the capacitor between two sources. That is called circulating. Yes, and this circulating current developed due to unbalanced voltage supply. Balanced voltage supply. So we can see easily here. Yes, due to this unbalanced voltage or voltage difference, there is some circulating power, and we know that we already see in a study in the parallel operation of the transformer. Yes, in the parallel operation of transformer, we easily say that there is some fixed arrangement. Yes, otherwise some power will be circulated among between transformer. So we don't want that. Why? That power is simply lost. Yes, so that is the one of challenge. Yes, so and third one point is to make bus voltage, yeah, their voltage relations will be within the range. Otherwise, whatever load you are going to connect on the bus, if your voltage is not constant within the range, see practically we cannot say voltage is constant. Yes, there is a variation. Yes, and due to capacitor which is connected in parallel to the bus, due to that voltage is balanced. But there is also some limitation. That means IEEE standard has only limitation 5 plus minus 5% variation for DC bus and plus minus 10% for DC. So it means what? There is allowed. You can change. You can not change. You can work in this time. Yes, your paper will be effective. Otherwise, your paper will be postable. Yes. So there are two sources just for discussion. There are two sources. The RC1, RC2 cable line impedance. Yes. And we are going to be control parameter that is group A. So that parameter is shown here, RD1 and RD2. Yes. And this is the characteristic for both sources, how we can make parallel operation, how we can say obviously parallel operation effective way so that we can achieve whatever objective we have discussed. So see, we have two lines, yes, and we can easily say their slopes are different. Obviously, slope depends upon the cable line impedance and two positions. Yes, and these parameters are constant. Yes, it can be changed slightly if temperature is going to change. Yes, and due to this different slope, we can say a difference of these two current I01 and I02. Yes, I01, I02 means these current are going to extract from the those sources, and we know that bus voltage is constant. If you are going to multiply this current into bus voltage, that is the power which is coming from that source. We cannot say effective equal power sharing until unless both are not equal. Yes. So question is how to achieve both are equal. If somehow we are going to make slope in such a way so that we can make this del I1 to what was it? Then we can say both points is going to lie at the center. Yes. Then we can say effective power saving. Yes. So how to achieve this? We are going to select RD1 and RD2. Because RC1 and RC2 we are not going to change. These are the pure parameters. Yes. These are the practical parameters. This can change according to the temperature. But RD1 and RD2 we can select in the controller. Yes. But thing is that when we are going to when we have selected RD1 and RD2 and due to temperature RC1 and RC2 are going to change, can we achieve equal power sharing? It means there is a limitation. Is the limitation at the constant temperature. So this controller scheme can work at a constant temperature. If temperature is going to vary, this controller scheme is not applied for effective equal power. That means there is a limitation. If there is limitation, we can work behind new paper. Yes. So what is the new paper? New paper will say if you are going to change RC1 and RC2, whatever matter. Yes. At the same time, RD1 and RD2 will be updated. Yes. RD1 and RD2 will update in such a way so that both points will exist at the same. Yes. So there is some space for new work. Yes. So I have read that also. Because RD and RD1 and RD2 I have modified with the help of Renewable. Yes. Due to some reason, our bus voltage is going to change. Yes. According to that, RD1, small RD1, for first one source is going to update according to the characteristic group current. Yes. So we can use adaptive control. With the help of adaptive control, we can update a small RD1. Yes. So how to achieve this? So this is the control scheme. Yes, distributed control scheme. So before going to adaptive control scheme, we want to give some time here. Yes. So yeah. If you see this is the DC source. Yes, this is the DC source. Yes, this is the DC source. And this one is converter. Obviously, we are going to use boost converter if you have PV source, because their voltage is small compared to demand voltage. Therefore, we have to have boost converter. So this is the DC source, this is the boost converter, and after that there is cable input, and this is the DC power. Okay. Similarly, there are three sources. Yes, their cable and impedance are different. Yes. Now objective is to make equal current. Yes. So whatever current is coming out from this source, it should be balanced, not balanced, equal to other two sources. Yes, other two sources. How to achieve this? That we have discussed. We will work. We have to work under controller. Yes, or based on the group. Yes, not only based on the group controller scheme, we have to manage RD1, RD2 in such a way that means we can achieve I1 equal to I2 equal to. Yes, so what we have done here. So I have sense current. I have we have sense voltage. Yes. So this is the source voltage, input voltage, and this is the output converter voltage. Yes, this one. Yes, and output of this converter is yes current. Yes, this is the per unit current. This is the per unit current, because we cannot say that all sources have equal power capacity. Because someone has 100 watt capacity, someone has 200 watt capacity, like that. So there are three sources, and all three are different power capacity. Therefore, we have considered per unit. We have considered per unit. Otherwise, we have to actually change this difference current. How to generate this difference current? First, we have taken low pass filter and pass this source voltage, and now it is free from high frequency variation. Yes. Now we are going to compare with this V0. Yes, V0I reference. Yes, because V0I is nothing but this is the bus voltage. Now we are going to this take reference. Take difference from the reference value, and after that we are going to take here, yes, PI controller. Yes, in that PI controller there is group parameter also, that is the gain factor, and that value is going to multiply with the output voltage and again divide by the input voltage. It means this is input, because this multiplied with this is equal to input power, and input power is equal to output power. We have considered ideal. There is a limitation. Yes. Again, there is open for new one. So this is the difference, and we are going to send to the communication channel. Yes. So in the communication channel, this communication channel can work based on some control algorithm. So all three currents are going to send to this communication channel. After getting average of this signal, we will again receive the average current difference. And with the help of static current control, yes, what is the static current control? There is two input parameters. One is the actual current, other one is the reference. With the help of comparative, yes, we can generate PW. Yes, so there is only one PI controller. There is not cascaded PI controller. If you see the previous work for same objective, so this one is the previous work, which is published during 2013. You can observe here, there are many PI controllers. Yes, this is for voltage, this is for current. If you observe this controller scheme, there is a voltage loop. Yes, there is current loop. Before that, yes, current loop. So both are interconnected. If you are going to connect in that way, if you are going to implement, there is a question, there is a challenge behind implementation of accurate data. Yes. So these challenge we have overcome here. I have used only one PA controller, another one is a distributed pattern control. So there is no issue for tuning data. Yes. So in that way, we have generated new data. Yes, it is published in the EIP journal. That is the Renewable Energy Code, and based on that journal, so these papers published. So my objective is to say this: behind this course or FDP, yes, especially for researchers, we have to see the intent. If we are able to success for seeing intention, easily we can find the solution. Yes, somehow and some level we are going to solve some problem. We will believe we can say that is a yes. So this is the adaptive. Yes, this is the adaptive. This is the adaptive. What we can say is distributed controller. Yes. So adaptive means what? If you try to observe here, same thing, the phase current controller, again, here reference here, yes, and output voltage we have taken reference from here. So after getting this reference, we have used such system here, and output of this, that is a del RD. Del RD means how much difference of the loop gain is going to modulate. Yes, it depends upon the actual voltage area. Yes, so input is the voltage area. You can see that input is actual voltage area. If there is a difference, according to that, del RD is which. Yes, that means we are not going to consider here RC1 and RC2. We are going to consider bus voltage difference. Yes. So bus voltage difference means this bus voltage difference and this is the actual voltage. If there is some error, according to that, del RD. If there is zero error, del RD will be found. Or zero, because this del R plus RD will be constant. Yes. So if there is no error, that means value is zero. That means del RD only RD constant. Yes. So del RD will be generated according to the how much bus voltage difference is. So this is this scheme is called adaptive distributed. Or in that way we have achieved same objective. Okay. So this is the controller scheme. This is the characteristic. Yes. This is the characteristic. See, Hybrid logic system is well known for knowledge. Yes, if you have knowledge, then we can implement this. If you don't have knowledge is what? For implementing Hybrid logic? No. Knowledge means system knowledge. How system behavior is going to change? Yes, we should have knowledge about the characteristic. Then we can implement the Hybrid. Yes. So and this is the membership. Yes. Question is how to select the membership? Depends upon our choice. Yes, if you can select here 7, you can select 5, you can select 3, you can select 9. What is the objective? Objective is to achieve this characteristic. Objective is to achieve this characteristic. If you are able to achieve this characteristic, the help of high membership is okay. If you are going to achieve this by 7 membership, okay. Yes, no. Depends upon are you going to achieve a smooth characteristic? Answer is yes. Then you can consider yes for the result. So this is the hysteresis control. This one is the what we can say center line is the reference current. That is the average current which is coming from the communication line. And what is the this triangular? It is the sensing current. Yes, which are going to vary. They are going to change. Obviously, that current has some ripple, and due to that, we can able to generate pulse. Suppose this current is constant. Can we generate pulse? No, cannot able to. Yes. So pulse depends upon the how much band you have there. Yes. So if you are going to decrease this band, that is a daylight, you are going to decrease daylight dash to 0, you may not generate PW. But if the thing is that if you are going to increase daylight, yes, also you may not get PW. Why? Because this variation becomes constant. Yes, so we should select in such a way so that PWM can work in the particular band. Yes, so there is a skill limitation compared to PI controller. Why? Because we are using renewable energy sources, we are using renewable energy sources, and we know that this is the intermittent source. Yes, if this is the intermittent source, means power is varied. If power is varied, means current is varied. If current is varied, that means their frequency will be changed. Yes, according to that, their filter will be changed. Yes, so these are the limitations here. So finally, what we are going to say that there are various controller schemes. Thing is that which one is the best depends upon the practice. Yes, we cannot say previous controller scheme was bad. No, that is also good. This scheme is also good. Thing is that where you are going to. Yes. So objective is to publish the paper, not only publish the paper. We also say that we are going to overcome that limitation. Get not. So if you are going to claim that we are going to overcome that limitation, means in some special case, this controller scheme can be improved. Yeah, that controller scheme can be improved. Yes. So objective is not that to generate or to propose controller scheme for all types of systems. Yes, that cannot be done. Yes. Is it not? So in that way we can make new research. Yes. So that is the limitation. And then see here band is heavy. What is the limitation? This controller scheme is very useful for especially renewable energy. Why? Because their band is going to change. Why band is going to require change? Because your source is going to change. Because renewable energy sources is called. Therefore, there is required wide band. And this wide band we cannot achieve with the help of PI controller. Therefore, this controller scheme is useful for renewable energy. Yes. So that is the limitation of previous controller. Okay. So this is the controller stability discussion. Yes. So stability discussion with the help of pole and group placement. So for variation of group gain, for variation of the communication delay, we can see here all pole zeros are placed left side of the reactive. Therefore, we can say that our system is stable. Yeah. So we can with the help of MATLAB, we can easily say equal power sharing with the help of proposal. These are just verification and a different scenario we have taken the result. Is it not? And this result based on the opera, not popularity, based on the TS. Yes. If you observe, there is no basic difference between the TS space and popularity. If you are able to take anyone, we can easily claim that we have performed in real time. Yes, we have performed in real time. And reviewers are able to accept these results. Because some paper, especially in IEEE, smart grid, IEEE, sustainable energy, they have published many papers based on OPLRT or DSK. Yes, right. So we can able to generate the paper. Yes. So these are the discussion. Yes. So finally, summary is adaptive distributed controllers we propose in order to minimize still there is an increase. My trade-off between effective load sharing and the work voltage. Yeah. So thing is that we cannot say effective equal load sharing and work voltage together. Yes, if you see in the group characteristic, yes, if you are going to achieve equal power sharing means del I equal to 0, yes, we cannot say that at the same point voltage regulation will be also 0. Yes, if del I equal to 0, it doesn't mean that del V is also 0. Yes, but thing is that del V will be exist, but within the yes. So it is based on the voltage loop control, dynamic loop gain, and phase current control. We have discussed already. Yes, as everything we have discussed, analysis of the force control scheme, which has done MATLAB and Simulink and verified with a real-time simulator. In that way, it can be published. Okay, so I want to stop here. Yes, if you have any question, it is welcome for me. Yes. So whatever your question may raise, I have discussed during the session. Because see, we can think at my research. Right? So our main objective to organize this FDP or sort of course based on this microgrid to learn how to see, how to implement, how to visualize the problem of the macro. Yes. So microgrid already started. Yes. Right now, hybrid microgrid is started. Yes. So there are various instruments are working here, but still there is a difference. Now there is the open table to solve new work. Okay, thank you from my side. If you have inquiry, you can ask either online or offline. Yes. Yes, call me.
Sir, when you are designing the controller, the traditional method is we take the input current output, and then we design a PID for current control, this one,
Yes.
and then a PID for voltage control. And you are saying that this method is not actually implementable. So you have revised it and you are using hysteresis control. Explain again what is hysteresis control? Yes.
This one is the hysteresis current control, which are going to work like this. Yes. So hysteresis current controller means what? There is a block, and if you are going to implement, there are required comparator. Yes, comparator means what? This one is the reference signal. Yeah, you can make two signals from this signal. One is plus daylight, another one is night. So it becomes band. Yes. Now you are sensing other one is the real signal, current signal, and you are going to compare. If it is equal to this level, it at that time becomes 0. Now, as soon as it becomes 0, that means load and source are disconnected. Therefore, current is going to decrease. Yes. When it is going to reach at this band, at this time, your switch will be turned on. Therefore, source is connected to the load. That means current is going to again increase. In that way, this PWM is going. So our objective is here to generate PWM. But if you see here, in this case, PWM generated from here. There is a reference signal. Yes. And this reference signal is going to compare with the one analog signal. or we can say comparative modulating signal. With the help of we can able to generate PWM at constant frequency. Though you have taken comparative signal at constant frequency. Yes. So they are frequency constant, but PWM is going to change according to the this reference value. And this reference value depends upon this PI controller as well as this PI. Yes. But point is that they are band within the constant. First point. Second point, if you see the implementation, there is somewhat difficult to implement in cascaded form. Somehow it will be implemented, but thing is that what are the methods? Practically, I have mailed to all authors, special authors, those who have published in the IEEE paper. I have asked, how did you implement this PI controller? They have simply said heat and drive. Yes, what they have said? Heat and drive. But thing is not that to implement by heat and drive. Objective is to implement proper way. If you are going to pursue PhD, yes, and during difference you will say I have implemented by heat and drive, immediately there will be negative mark. It is not. So sometimes the reviewer will ask this question: how did you implement this? Which type of process you have applied? If not, that is the secondary task. Main task is to implement the objective. Yes, if you are able to achieve accurate PI parameter, obviously you will achieve the objective. Then you can claim the results. That is the main task. But behind this, someone asked how to implement it. At that time, we cannot say we have implemented by heat. It is not. So behind implementation, research loop. My question is not that to give answer in front of different experts. Our main objective is to implement the objectives. Yes. So with the help of HIS control, we can implement for renewable energy sources, because these sources based on we have identified. Yes, but this PI controller cannot work for wide range of the input source or wide range for the input output load. Yes, yes, somehow we can control the load, but we cannot say somehow we are going to control the renewable energy sources, because their energy is called intermittent. In that case, PI controller cannot work effectively. Yes, but hysteresis control, due to hysteresis control, their bandwidth is going to manage according to their current reference. Yes, and as well as with the help of selecting daylight. Because daylight value is also we cannot say we have taken by any such method. Yeah, we have selected daylight by own way. So there is a limitation. But still there is a limitation. See, I have did work and I am showing limitation in my work also. Yes. So in that way we can make new paper here. Yes. So I am giving chance for you to prevent new paper in this area. Yes. Okay. Thank you. Thank you to everyone. And we will meet in the next session. Next session will be started from 2 o'clock. Yes. And by Rajesh Kumar, he had joined NIT Kurukshetra from NIT Renewable. He did PhD under the Dr. Professor Sir. Yes, IIT Delhi. And not only that, he published 2 patents, as well as he had taken the project. So he did really good work. So today we will see the lecture from 2 o'clock. Yes, so don't miss anyone. Okay. Thank you to everyone. Thank you.